The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello, everybody. Thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally gotten.
Hello, everyone. I'm geologist Philip Ong, here with Mr. Dane DuPont from HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, July 18th, 2024. Kilauea is still swelling, earthquaking, but no lava at the surface at the present. So we'll get into that a little bit and touch base on tomorrow. Is going to be the 50-year anniversary of the July 1974 eruption, which was in the summit in conditions pretty similar to what we're seeing today. So that's a little bit of what we got on the menu today. How are you doing today, Dane?
Oh, doing pretty good. Yeah, it's a very relevant little topic that we have, and continues off of the Mauna Loa talk that we had previously, and the presentation that we did with Lou, who not with us today, but we'll be back next week.
Right on. So yeah, thanks, Dane. Is there anything we want to address at the top before we get into it here?
If you guys got any questions, we're going to be doing them in two parts. First part will be on the volcano conditions now, and that'll be in the first segment. And then the second part will be focused on the 1974 events and the events around that. So we'll take questions in separate waves.
Right on. Thank you, Dane. All right, so let's get ourselves set up here and get ready for our summary. All right. So, aloha everyone. This is our Hawaii volcano summary for July 18th, 2024. It's been 6 weeks since the Southwest Rift eruption on Kīlauea, and 2 weeks since the heightened earthquake swarm on the Upper East Rift. And the volcano is still swollen and still gradually inflating with more magma. If we look at the South Caldera GPS north to south, we can see that the caldera has been expanding in length. So despite the recent adjustments, there's still magma building underground underneath the summit area, and beyond that, in fact, as well, as we'll see shortly. Here are the earthquake rates per day over the last month. So earthquakes have been fairly active in that Upper East Rift connector and South Caldera area, but at level is much lower than we saw at the end of June, beginning of July earthquake swarm in that same area. If we look at the tilt meter, this is a sand hill station, we can see inflation both from the South Caldera area and from the main caldera area as well, at a pretty massive scale here. We're looking at many tens of microradians of change each week going on here. So pretty good buildup there. And our most recent satellite radar image is showing a bullseye down here in that South Caldera area, as you would expect. So that's where the magma is building underground. The earthquakes are concentrating more so on the East Rift area than in the Southwest. But really, it's this whole summit area within about 5 miles of Halemaumau that's been rising, uplifting with magma building underground. So that's the story on Kilauea. Mauna Loa over the last month is much quieter. There have been some earthquakes showing magma still filling and inflating at depth, but nothing very major. And we can still see that long term, the volcano is also spreading its caldera north to south, getting wider as magma builds underground. Looking at the ground tilt for the last month at Mauna Loa, we're back to our normal gradual inflation after seeing a little bit of a steeper adjustment last week. So back to our regular background normal on Mauna Loa, and nothing to be concerned about there. And that's our Hawaiian volcano summary for today. All right, so now we can go to our observations, and we don't have a whole lot of new imagery, but we can go through the webcam views. And so here's our main KW camera view, showing most of that main caldera with this degassing ring of sulfurous minerals building here and causing this discoloration in the central part of the cap. We've seen those grow over many months now. Our thermal camera is now calibrated and is showing a maximum temperature of less than 50 degrees Celsius. So everything is fairly cool there in the crater. You only see a few hot spots where the gas is coming out. still shown as brighter dots here. Otherwise, nice views from the V1 camera. This is from the live feed, a little bit more zoomed in there. You can see the more recent eruption side of September here in the background as well from last year. Down on the southwest rift, our most recent eruption site was somewhere around in here, but you don't really see much fume coming from there anymore. Just some low-level clouds blowing across the field of view here. This is our B2, is it? B1 here, and then B2 coming up. More inner caldera views here. B1 and B2 there. From Kīlauea, the K2 camera, showing a little bit more of the downdrop block area here to the left. So it's been a little while since we've stepped through these cameras, and from Mauna Loa, today the clouds are low enough where it's blocking most of our view down here to Kilauea. So that's what we can gather. Not a whole lot of visual change at the grand scale in Kilauea, but it's good to check in once in a while on those visual observations. So we'll move on now to our earthquakes. And we'll start off with this island-wide map, which is currently showing the last 2 weeks of earthquakes. And these are colored by depth. So where's my key here? Right, the reds are the shallowest, the blues are the deepest, and orange and yellow is in between there. So this is the whole last 2 weeks. We have our Deep Pahala earthquakes coming from the hotspot as usual here. We have our Kilauea adjustments happening all through here. We'll zoom into that in a few minutes here. We've got some blue background deep events occurring sporadically across the island. And then we have a few earthquakes on Mauna Loa's southeast flank, and then also here on its northwest flank as well. So a little bit more of adjustment on Mauna Loa, corresponding more to last week. If I click this to the last 2 days, you'll see most of that background disappear. So really it's been more so Kilauea and a few southeast flank Mauna Loa adjustments here within the last 2 days. So let's zoom into this a little further. And here in the last 2 days, you can see that there's been earthquakes still in this main caldera area. Not quite as many in the South Caldera, although there have been some of those within the last week too, just not in the last couple of days. And you can see the cluster events occurring both here right by Keanakakoi crater. And that's this one right over here, Keanakakoi. Right, this is within that main caldera of Kilauea, but a separate crater than the big central crater of Halemaumau right in there. Just for a little orientation, this is an area we'll be talking about more today, so worth spelling it out for you guys. And then we also have this cluster along the Upper East Rift connector right in here as well, where it often flares up by this Puhimau thermal area right in there. It's this little discolored spot right in there. So that last 2 days, here's the last 2 weeks, just to fill it in some more. You can see there, that's the pattern of where the ground has been shaking as a result of pressure building all around here, not just in these areas where the earth is quaking. So that's where they are. There has been, this is the last 2 weeks now, so it is picking up a little bit of that aftershock sequence of that south flank earthquake, but in the last 2 days, those are not present anymore either. Right, so that's the map. It's colored by depth, and I also like to show the map where it's colored by time. So now our key is that the last hour is red, the last day is orange, the last week is yellow. So you can see where the most recent events actually have been. Right? And there you can see where they are on that East Rift connector, Kauai fault zone, and South Caldera areas. Right in there. If I pull it back to just the last day, you can see it's still ongoing at moderate levels there. So those are the recent earthquakes here on Kilauea and elsewhere on the island. Kilauea is the focus for our story today. So we'll move from here to our monitoring. And to recap, the USGS has been putting out daily updates all week, but I'll just focus on the one from today. to recap where we are presently, which is overall that of no significant change. There has been variation of earthquake counts beneath the summit and upper East Rift connector, but overall there have been somewhere in a range of 50 to 100 earthquakes at either location all week or so. The USGS is saying that gradual inflation of the summit and upper East Rift zones or upper Rift zones continues. This is the East Rift and the Southwest Rift connectors. And as has been common over the last few weeks, their prognosis is unchanged, that with big changes in seismicity or deformation, there could be a new eruption. But presently, there are no signs of anything imminent. So we have a new SO2 emission rate measurement of 100 tons per day that was taken yesterday. And otherwise, there is not really anything to highlight that's happening elsewhere in the volcano. Instead, we can come to look at the monitoring signals and poke around a little more ourselves. So this is the last week on Kilauea to start. This is the ground tilt. This Uwikahuna station was one that was recalibrated a couple weeks ago. And so we were told for a few weeks not to trust the absolute numbers on the graph here, but rather to take it as a qualitative indication of whether the volcano is swelling or not. And so based on that, you can see that it is swelling. It's come up some number of microradians that we can't say accurately how many, but it is showing variations also that look like our deflation inflation cycles that we were seeing previously on this station. So perhaps it is stabilizing and showing some of that background variation superimposed upon the longer term trend, which is that of pretty gradual climb of the ground tilt here. And over that same time, the earthquakes have been fairly stable, earthquakes per day, around 100 earthquakes per day. You can see that earlier in a week, there were a couple of days down in the 60 to 70 range. And the last couple of days have been in the 130 to 140 range. But on average, it's been about that. So little pulses of cycles still ongoing. And it seems like they began more so in the South Caldera at the end of like the first part of this past week, and more recently have come back to the upper East Rift connector, which is the same pattern as we saw the week before that. So that little ping-ponging back and forth of the inflation center, of where the magma is collecting underground, of where the signals and instruments are moving as a result is shifting still. So earthquakes, depth versus time for the last week. Because the scale is showing every 10 kilometers, we don't see the resolution within the upper crust where all this action is happening. But we can see that this orange band is showing us almost all these events are in that upper part of the system and not deep down in Pahala or in the flanks of the volcano either. So that's all interesting. We're not really learning much different here. There's been a similar pattern for a while. Interesting and curious pattern, but not really changed a whole lot. What is a little different in earthquakes is that lack of South Caldera earthquakes. There have been a few right in here in the South Edge, but overall, these have been decreasing over the last couple of weeks and being taken up instead in this section of the Upper East Rift connector. And as we've been describing for a while, seems to be the area that is undergoing the most adjustment right now, and we'll look at that with our GPS here soon. So for now, we'll leave it at that, and just point out as well that there are south flank earthquakes occurring in this most proximal segment of the south flank to the summit and Upper East Rift connector too. So as this area is adjusting and presumably trying to push outwards from the center, you can see this area here is also adjusting, and that's why we had that 4.1 last week right in here. Okay, we'll skip over the cross section and come to our last month view. So in our tilt, here is our long-term inflation at Uwikahuna, perhaps with some instrument noise before the calibration and some untrustworthy numbers afterwards, but still an overall great rise. We can't believe that it's exactly 60 microradians, but certainly it's been a great amount of ground tilt there. This station, a Sand Hill station, was calibrated digitally, so it does not have that adjustment time. And we can see here that even within the last week or so, that we've come up perhaps 10 microradians or so in the South Caldera area. The main area in the summit did show deflation week before last, but has come back up and is also now in sync with the South Caldera signal and with this Uakahuna signal as well. So everything's just showing we're still swelling down there, magma is still coming in. And here are the earthquakes in that East Rift dominated pattern compared to the counts we had in that same area back at the end of June. So quite a lot lower numbers of earthquakes, but still adjusting in a similar way. And those are earthquakes per day and earthquakes per week. We can see here that we've actually been declining week over week, but we're still above our background lows in between our eruptions, or when we don't have so many adjustments ongoing. Really, it's been back before October, this little gap right in here when we really had the last background time, because that was the first injection of magma into the Southwest Rift and intrusion earthquake swarm that occurred in October, followed by another big one in January to February, and continuing all the way to the eruption that we had in the beginning of June. So lots of adjustments to the Southwest, and earthquakes per week have been elevated across the board since October. But you see that here, even within the last month, we're a little bit higher than normal, although coming down. For the last 5 years, we count earthquakes per month. And so clearly we are still quite elevated. If you look at the last 6 months or even the last year from now, we're at somewhere upwards of 3,000 earthquakes per month most of the time, compared to take any of these previous years. That was a pretty rare thing to happen. And so certainly more earthquakes ongoing now, and adjustments. A lot of those are small, but occasionally you're getting these bigger ones coming through as well. So those are the earthquake counts. And for GPS, at the summit, we've seen this line that measures a north and south distance sometimes flatten out when the inflation center shifts south of the caldera, and then it shifts back into the caldera and it accelerates again. And here we are in the accelerated phase, showing inflation in the caldera right now also. But what we're seeing now is maybe inflation not only in the caldera, but in the caldera and in the Southwest Rift and in the Upper East Rift connector. So it's really spreading across a large area now. And we'll get to that when we come to our individual stations. But to finish off the GPS distance lines, we have a station on the Middle East Rift as well at Pu'o'o, and that is showing a decrease of the distance between the two sides of the rift. And in fact, it looks like that has accelerated here within the last few weeks, the last week or two, which is really fascinating there. And so we'll get into that here a little more. So let's start off with, let me just come first to this map and come over here to the Pu'o'o station, is this one right here. We're at Pu'o'o, and so we can look here. These are now 2-year GPS plots, and if you have not followed us, this graph is a little different, and it's showing 3 different panels. This top panel is a east-west component. This middle one is a north-south component, and this bottom one is an up and down component. Right, so what we're looking for now is what changed in the last couple weeks, and there's really not anything major that's visible at this NPOC North Pu'o'o Crater station. So they're just going to show us the ground is still dropping there, and it's not like it's rising out of it all of a sudden because something's changing underground. So that's one end of the distance line. The other one is down here at Jacuzzi. I'm going to zoom this in somewhere you can maybe see it better. There's an NPOC. There's Jacuzzi. And so here's Jacuzzi. And let's go look at that one. And similarly, 3 panels, up, down. There's not been any major change. Maybe we're going a little bit faster to the south, but not really within the last couple of weeks. Not really a whole lot of change there. The answer is going to come in this last panel here, the east-west panel, or if I zoom it in more so you can see more closely. There's a lot of noise in this station, right? There's a natural spread of the data. And so this may end up evening itself out, right? But it does appear that now there is a trend that is pushing the station back to the west, where it was overall in a pattern of going east, right? And maybe this is within that range of the noise, but we also have these suspect data points way down here. And while these might get corrected, they are casting doubt that this trend is just noise. So we'll have to wait and see here. But if this is actually moving to the west as the only change, then if I come back to our map here, and if this goes west, it actually is getting closer to this station, and that would explain why that distance would go down on our graph right here. So we'll see. It seems like it's transient. The most important thing really is, if we look at the map, that both of these areas are still dropping down, going downwards. And so magma is not filling below there, right? They're adjusting as all the blocks, as all the dominoes surrounding the main caldera are getting shuffled around and trying to fit in and rotate according to their boundaries there. So that's the GPS just on the East Rift, and we can back it out as well. And maybe I'll start by just coming to our panel view of GPS. And to do an overall survey on this, I'll draw your attention to the bottom panel of all these stations. So all I care about is what's going up and what's going down. So Uekahuna, this is the northwest part of the main summit caldera, is going up. In the east, the caldera is going up. Southwest, it's going up. In the southeast, it's going up. We go down to the southwest rift, 1.5 miles away, it's going up. 4 miles away, close to the eruption site, it's going up. It's actually going up pretty fast right here. Look at that high rate. It's the fastest rate of upward movement we've seen here, going back to October, in fact. And further down, if we get down to 8 miles down the southwest rift, that's now too far. We're not going up anymore. We're still flat to down. Right? That's the southwest rift. We go to the south flank, and Ahua is going up. Puhimau up. Devil's Throat's going up. Right? That's about, if we look at our panels, that's about as far as we can get as Devil's Throat right there. All the other stations are showing flat or down on their panels. A couple exceptions right here, Hilanapali and Kipukanene, which are adjacent to the southwest rift and Kauai as well. So that doesn't quite fit my grouping, but it does fit the geographic pattern there. And everything else, nothing else is coming up here. On the east rift, down, 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 down everywhere. Right, so I'm gonna come back to the map here, and now I can point out where those stations actually are. Devil's Throat is that one, still coming up. Right, so that one is coming up, but this one is not. Over here, this is Makakipukanene, it's coming up. But this one over here, the goat pen, it's not. Over here, this is our eruption site that's going up. And over here, it's 8 miles away, too far, and it's not. So somewhere right in here is our boundary. It's about a 5-mile radius from the middle right there. It doesn't quite go on this edge like that because of the caldera comes against Mauna Loa, but you're looking at something like that as far as a range of what's swelling in a volcano, which is not too far from our southwest rift, Kauai, upper east rift triangle. Maybe that's a little bit more accurate as well of a view of which area is swelling and building pressure. So within that area, now let me look at this 10-year GPS. And so we're going to look at a very similar thing, just a bottom panel at the up and down. So the northwest part, Uekahuna, which is fixed, did not collapse all the way into the crater. You can see that this big change in the data across all the plots here is 2018 eruption and collapse. So the elevation of Uekahuna before that collapse is not too far off of where we're reaching now, in fact. So at Uekahuna, we've largely recovered to the northwest. On the east side, we have not. Here's how high up the ground was, and we're not quite recovered to there. Right, so it's a little bit asymmetrical. We're more recovered in the west than in the east. We go to the outlet station that's in the southern part of the caldera, and it's showing a lot of upward movement as well, especially within the last year and a half. And it's not quite up to that same level, but it's getting close there. It's a little bit higher than the crater rim, a little bit further to the east. Right, so once again, the west is slightly more recovered there. Ahua, Puhimau, and Devil's Throat. So Ahua, right here, you can see is almost all the way back to its original pre-collapse elevation. Puhimau, it's a little further to the southeast, a little less so. And Devil's Throat, more to the southeast, even less so. So back to my map. Ahua is this one. Puhimau, Puhimau is this one. And Devil's Throat's over here. So really, of this whole triangle we've been drawing in, we know there's been injections of magma, intrusions, and an eruption in the southwest rift right through here. We see the ground has been coming up almost back to its original elevation all through here. But where it hasn't is more so on this side of this triangle right through there. So in that case, if we're filling our big balloon here with all these different connections of pathways of places a magma can sit, and the area that has the most room to reinflate is actually apparently over here. So if I show all the earthquakes and they're all clustering on the East Rift connector here, that does seem to jive, to fit together, to fit that pattern. Maybe not the only explanation, but that does seem to be consistent with what we're seeing here. So that was a little bit more of a deep dive into our GPS. I think I'll leave it at that for today. And we'll move over to our satellite mounts imagery. So mounts is an automated processing site that's doing captures of many volcanoes and scanning them with, or it's taking the data from satellites that scan a volcano every couple of weeks and computing these plots that are telling us how much distance the ground has either risen or dropped in between those passes of the satellite. So that's where it comes from. The most recent pass is this one right here. Our bullseye is right there, right on the edge of that South Caldera. The one from last week, I'll flash it up, was a little bit further in the Kauai. The one from the week prior to that was closer to the South Caldera. And the week prior to that, well, I shouldn't say with the 2 week periods, I should be saying. Prior to that, that was when the eruption occurred and that big intrusion flushed to the southwest from the summit there. Right, so back forward from that last eruption, the 2 weeks after that, the next 2 weeks, and just these last 2 weeks, showing how the inflation center has been migrating through the South Caldera area. Okay, so that is the monitoring data. A couple final things before we take our midway break here. We'll come in to check on our volcanic hazard, the gases. We're going to, as usual, come to our VOG measurement and prediction project, VMAP, from Manoa, where they're putting out a dashboard that shows where the VOG is coming from with the most recent emission rates. The emission rate here is being listed as 300 tons per day. Perhaps that's the 100 from the summit with another 200 from the eruption site. That's still perhaps passively degassing, or maybe it's just outdated still. But in any case, this shows, combined with the current weather conditions, where that VOG might blow to. And so you see it's in a nearby volcano area and southwest towards Nalehu and Kau, as well as into the saddle a little bit as well. So certainly an issue for people who are sensitive and nearby these areas, but otherwise, for the volcano, it's not too bad actually at this point. Right. Pretty good air in between eruptions now. And in a national park, the closest spots to the degassing site everything is in the green, as you can see here, and has been so for the history of this last 24 hours shown on the website here. So, but if you are a sensitive individual and you're nearby, then certainly take directions from the park and the park rangers. To round us out here, we don't always do this, but just to show how good the air is now on the island, here's our Purple Air Citizen Science Monitoring Network. We look at this a lot of times when a gas is bad, but just for comparison, when it's not bad, you can see the values are typically 0s to 1s to 5s across most places. Sometimes this Kahuku station spikes a little higher all through here, so there's something about that particular station, but overall you can see a very clean air island-wide today. So that is the hazard summary, and we will just finish up this first half with our volcano watch for this week, which is related to the gases, and so that's why we put it in here. Measuring volcanic gas. The answer is blowing in the wind. This is written by Christine Sealing, the USGS HVO gas scientists, associated with UH Research Corporation as well. And this article is showing the current gas monitoring instruments that are deployed downwind of Kilauea summit. So of these, you see there's 3 different colors there. The red one is a multi-gas. That one is measuring all different kinds of gas and the concentrations relative. So you're talking about like carbon dioxide, sulfur dioxide, water vapor, all the different gases, H2S, and relative proportions of those. That's the orange one. I'm sorry, the red one. The orange ones are high precision. They're measuring only SO2, but they can measure them at much lower concentrations. So they're there as well. And then they have this fly speck array, the yellow stations here, which are catching a cross-section of the plume under typical trade wind conditions when it blows from the northeast, right? And that blows the gas across this instrument array, and they can make measurements at that point in time. And so that's what's up there right now. 19 permanent gas monitoring stations, 7 portable ones. They measure either concentrations or emission rates, right? The concentrations being the multi-gas ones, and emission rates being through the fly speck array and UV cameras there as well. So one interesting analogy that they give here is how tricky it is to actually get gas data. Here's what they say. Imagine a scenario where seismometers didn't work every time it rained. So that's not really what happens, but let's pretend. In that scenario, you'd feel an earthquake and know it happened, but have no way to measure it just because the ground happened to be wet. So that's thankfully not how it works, but that is a way of thinking about seismometers that we kind of take them for granted that the gas scientists certainly do not. For a gas scientist to get a good measurement, they have to have 4 things: an aligned wind direction, the right wind speed, daylight to make their UV measurements potentially, and luck as well. Right? So the wind direction is going to blow the gas over their instruments. And not only does it have to fly directly over the instruments, you have to not have Kona winds where the gas might be blowing in a slightly different direction and not going over your instrument as well. So that's a potential that can happen. The wind can be too slow. So if it's below 9 miles an hour, then it's lofting straight upwards and also not flying over the stations. If the wind speed is too fast, if there's not a whole lot of gas coming out, if it's above 27 miles an hour, then it's basically getting thinned out too much, and you can't measure that either. So you've got to have just the right conditions, not too slow and not too fast wind to be able to measure it as well. And then there's the issue of location. So the most recent eruption was in a southwest rift, and it happened to occur downwind of all these instruments right over here. So that was the case, and so you just happen to have bad luck and miss the gas coming across all of here. So pretty tricky. We've got gas measurements. And so if you check the public webpage and it looks like there isn't any gas reported, it may just mean the wind is not cooperating and they are still chasing down the plume. So that's this week's Volcano Watch, just sharing a few more of the challenges of measuring the gases and why it's reported the way it is. So, all right, Dane, that's halfway. And with that, we'll take a break to say some mahalos. Are you muted?
I lost my I moved the screen and you lost my mute button. All right. Yeah, too many screens going on. So yeah, I'd like to thank everybody for tuning in today. We rely on viewers like you to help like, share, subscribe, all of those types of things that get this information out there, help us with the algorithms. I know you hear it all the time, but it is true. We also like to thank the Puna Strong and Kilauea Recovery Grants for helping support this type of content, as well as our other efforts in digital resilience. I'd like to give a shout out to everybody that has donated. We don't have the cool little graphic from Lou, but we've been watching, and we appreciate all the support. We are now in our summer donation drive. Just got it going. So we do take donations over on hveri.org/donate. Here's the link here. And yeah, every little bit helps, and we appreciate all the support that we get. I didn't get any questions, to be honest.
All right. Yeah.
Oh, there is
We'll
one.
keep going then.
There is one. I got one. Dennis asks, are there shallow earthquake stress relief from inflation in the East Rift Zone?
The shallow quakes, yeah, they basically are stress relief. Yeah, so it's inflation, probably both of the summit and East Rift together. That East Rift area has shown lots of earthquakes when just the summit's inflated in the past. I think what's different now than before, at least the times that I'm used to looking at the East Rift seismicity, is that the East Rift has been inactive for several years now, right? So when the East Rift Zone has been active and magma has been flowing through it and it's been hot and more part of the system, I think it was maybe adjusting more so in real time, and maybe now we're trying to catch back up in that area. That's why I try to show some of that inside of the GPS data, being slightly asymmetrical there, west to east, in that Kauai zone right through there. So yeah, that's probably true, Dennis. Yeah, it's a good observation.
One more from Bill. Asks, how many seismometers are there operating on the Big Island, and how many of those are on Kilauea? Who operates them and collects the data?
Oh, I don't have the answer, but this is on the USGS webpage, I believe, right? But it's not something I was prepared for here. So I want to say it's going to be something like 150-ish, 130, 150, something like that. They're all operated by the USGS HVO. The data is collected by them and then it's piped through to the National Earthquake Information Center. So there's a national syndicate that kind of collects and synthesizes all the data from all the different networks nationally. And so the USGS is on the mainland is the one who does that through the NEIC, as it's called.
Right. And then there might be...
many...
Oh, go ahead. Sorry.
No, go ahead.
I was going to say, and then there's also just we're not counting the random raspberry shakes that might be out there that individuals own, private individuals.
Right. Okay,
yeah.
So let's see here. The USGS webpage says HVO maintains about 60 stations on the island of Hawaii. So there you go. 60, not 100 and something. Right. According to the USGS site today.
All right. Yeah, I think that gets us through and into the special feature on 1974.
All right. Yeah. So yeah, our special topic today will be 1974. Let me get Google Earth up here and give an orientation of the area and the phase of the volcano that we're talking about here. So what I have highlighted here are the lava flows between 1971 and 1974 that are not Mauna Ulu, right? So Mauna Ulu is the vent that's right here, was active for 5 years and put out this big scar of a lava flow towards the ocean. That was a long-lived eruption from the Middle East Rift Zone right through here. That's kind of the background or the prequel to our story, really. Because what matters is that during these certain phases, the lava was not coming out of Mauna Ulu so effectively. The vent was stagnating, the pathway was constricting or getting blocked, or however you choose to think of it. For whatever reason, there was too much magma coming into the summit area, and it was not able to go out to the East Rift, right? So that's where our analog to today actually is. We're in a similar situation where magma cannot go into the East Rift, and anything that's coming into the volcano has to find a space to fill and be accommodated underground. So in this period from 71 to 74, August 71 is, let's see, let me uncheck them all, and we'll start from the beginning here. August 71 was a fissure at Kanakakoi, right through here, and the caldera floor that put lava onto the main caldera floor right there. That was following a couple month slowdown of lava coming out of Mauna Ulu. So this basically interrupted the Mauna Ulu eruption. And following that, magma then broke down the Southwest Rift in September of 71, all the way down to there, right? Then lava actually found a way back to Mauna Ulu for a couple years, but when it got disrupted again, there was an eruption at Hiaka crater right in here, right along the trace of the Kilauea faults. We had fissures coming out, both in Pauahi and Hiaka craters. In November of 73, there is another fissure just upslope on a Kilauea fault trace of Mauna Ulu as well. In July of 74, I'm zooming back out. This is what our anniversary is here. That's the pink flow. There it is right there. That's our focus 50-year anniversary tomorrow, right there. It breaks out through a very similar location and fissures as a 71 eruption, right between Kanakakoi and Halemaumau, and puts lava both into the caldera and south, all the way to near Ko'oko'olau crater on the rift zone there. And then to finish 74, in September 74, there was another eruption in Halemaumau right in there. And December 74 is the Southwest Rift eruption down in here that was very similar to our June 3rd eruption of this year in its location, although not in its extent. So this is all the places that magma broke out and leaked out when it couldn't get out through the Middle East Rift right through here. And these are the locations that are all in play for what's happening with Kilauea today. We just saw an eruption from the Southwest Rift very near the December 74 site. We've seen plenty of summit eruptions like the September 74 eruption through here within Halemaumau itself. Seen plenty of those. We have not seen an eruption in the shallower Southwest Rift up through here. And we'll get into that, but it's thought that between 71 and 74, there was a change in Mauna Loa. Mauna Loa was pushing more so in the later years, and so prevented an opening like 71 from occurring beyond 71. And that's also true today. So as we saw from the eruption coming out down here in the beginning of June and not anywhere else, similar conditions. So maybe we can take this September 71 off the board. That's probably not in play as much right now. Right? But we're having earthquakes all in this very same area as occurred in 74 and earlier as well. So it's still possible for us to have an eruption out of this Kīlauea area in the South Caldera, like 74 and 71. It's also still possible for us to have eruptions from the Kauai close to the southern end of this upper East Rift connector near Hiaka, Luamanu, and Pauahi craters. Hiaka and Pauahi craters down through here. So it's in that context that we're sharing this anniversary eruption in pink here. Is that these are the things that might happen again, potentially soon or not. It could be different, but it's a good time to look back in time and see what this was like. So we'll start visually with this map. We showed you guys that Google Earth, but here's a national park map showing the traces of the fissures. And there's black lines there and the extent of the flows from July 19th to 22nd. This was a 3-day eruption, although most dramatic activity lasted less than a day. Right, that was when the fountains were active across the entire extent. The second and third day, the fountains had localized to the caldera floor fissures, and there was low fountaining feeding this flow for the last couple of days after that big pulse on July 19th, 1974. So what did it look like? Here is that flow as it was crossing the chain of craters road near Puhimau crater. Right there. Clearly the chain of craters road covered in multiple places. This is Kanakakoi crater itself. So the first fissure opened up was this one right here on the bottom of the southern crater wall. Then fissures open up further towards Halemaumau and up on the rim as well there, and also on this side as well here. This photograph is taken pretty early on. You can see the floor of Kanakakoi is still covered in lots of cinders, which are largely the high fountain products of Kilauea Iki in 1959. That tall fountain of lava sprayed a bunch of cinder and tephra that fell off in this direction and filled the bottom of this crater. So here, this lava flow is sending this fountain, this fissure, that the fissure has got a crack along the bottom of the crater here. It goes up the wall of the crater, it resumes on top of the crater, and later on will be another one on this wall over here as well too. Nice 3D cut through the crater with its fissure there. But this flow that will eventually fill the whole bottom of the crater is still making its way across. It's only halfway across the crater floor here, continuing to move across there. So pretty early on, before even this western segment of the fissure had opened up right through here. But pretty dramatic. This must be, I would guess, 80, 100 feet deep, something like that. So pretty big hole in the ground over there. In the end, the eruption filled the crater with nearly 20 feet, 6 meters of lava all the way across the bottom once it came all the way across. This is a view zoomed in from looking across. This is probably taken from Uikahuna area, more or less. It's hard to see exactly what's going on here. Kanakakoi crater that we're just looking at is hidden back right in there. So that other fissure would have been down at the bottom. It goes up the wall, it comes across, and that's this fissure over here that's on that southernmost part of Kilauea. Then this here is the crater rim drive, goes right through there. In between Kanakakoi, crater rim drive, and the edge of Kilauea caldera itself is where these cracks opened up, actually going down the wall and on the caldera floor itself down through here. So it's pretty spectacular view of multiple fissures all in the same line of sight, different elevations here. This image is taken from Waldron Ledge here. You can see the little rock wall there and fashion of the day. And then there's always that one guy who's going to stand right in front of everyone else in front of the rock wall. Here he is, immortalized in the USGS image of how spectacular this was for people to see in those early hours in the first day. Really dramatic sights, and was really one of the highlights of viewing on Kilauea over the years. So that was that fissure. And closer to Waldron's Ledge and Volcano House, this is that big flow that was sweeping across the caldera floor. It was very thin, but moving in a big sheet. And here you can see the leading edge of that sheet marching across the floor of Kilauea caldera there, Kalua Pele. So here's an aerial view looking down. We'll start from the bottom, scroll all the way down. So this is the main caldera itself. The lava was cascading into here and then sweeping around towards Volcano House that way. The 71 fissure was actually this crack right here. The 74 fissure there. Lava funneling through here and funneling into that fissure also, and then both of them into the caldera floor. But also, there was another segment of fissure right through here. Also, one of them feeding back into Kenikakoi to the south. Kenikakoi, here it is, the whole crater floor filled with lava, and 20 feet of it there. The crack, the fissure that went across the back of it, was right through here. You see a little bit of a layer of tephra, like this kind of amorphous mound right there against the crater wall, that big pile of cinder right there. That fissure actually went up the far wall. It goes across there. That sent this big flow all the way close to Ko'oko'olau crater. It's way further over there. This is the Puhimau thermal area right over here. So that's a big flow that went down and crossed the chain of craters road near Puhimau down in here. And one other little segment that doesn't show up anywhere else in these photographs, right through here, was this 3D fissure segment came up, and here you see a little bit of that very small flow that came from that little segment of fissure on the upper rim there. Looks like there's some vehicles here. Looks like they're clearing the road already after the fact here. So pretty quickly they reestablished that pathway for visitors. So those are some visuals of the 74 eruption. There's also a volcano watch from 2012 that recounts a little bit of how this was for the USGS staff. Bob Tilling was the HVO geologist who was alerted by a 3:45 a.m. tremor alarm, rushed over to the USGS HVO building. They were able to see in the distance the glow of Mauna Ulu's lava lake that was still dying off at that point in time. And then it would be 10:30 a.m. or so when they saw seismicity ramping up. And at 12:30 p.m., they see 100-foot high fountain erupt from the base of the south wall of Kenikakoi crater. Then fissures erupt north of Kenikakoi between a crater rim drive and the caldera. Those lava flows pour into the caldera through little gullies into the crater. And lots of cascades. There's also a fissure that opened up in the forest east of Luamanu crater. I haven't mentioned this one yet. Across the Chain of Craters Road, if you drive the Chain of Craters Road and you pull over at Luamanu, that's the feature that you see there, most prominent. Those fissures also filled Luamanu crater with about 50 feet of lava, although 2/3 of it drains back into the fissure and leaves a high lava mark on the crater walls in there. So lots of different fissures, lots of different areas all across there. Low fountains continued through Saturday morning, declined on Sunday, and by Monday morning, all activity had ceased. And a tremor, which is our seismic signal showing movement of fluid underground, on the Middle East Rift at Mauna Ulu also stopped following July 22nd, and so that marks the official end of the Mauna Ulu eruption as well. So this whole phase, this whole sequence was the whole concluding chapter of Mauna Ulu. So one final point here. Bob Tilling finally recalls taking a brief break from HVO work to enjoy dinner by lava light with his family at the Volcano House, where from the dining room there were stunning views of the erupting fissures. So pretty cool to imagine what was happening in 74. I've not found any video of this anywhere. I just have these few images. some other graphs as well to share with you guys. So let me just show you guys. This is professional paper 1613. That's by Jack Lockwood and others, including Bob Tilling, Rob Holcomb, Fred Klein, Arnold Okamura, and Don Peterson, right through here. This paper is actually catching all 374 eruptions, right? So it was a really active year. And so I'm going to focus on just a little bit of this paper, which is that 74 segment. Right? So we kind of recap how the alarm sounded and woke up Dr. Tilling. There was one last field party that went to Mauna Loa and got there at 9 a.m. and saw molten lava during a crustal overturn of a lava lake more than 40 meters below the crater rim. That turns out to have been a final view of lava at Mauna Loa. And that same party noted many new holes and cracks on a chain of craters road south of Puhima crater, which is really showing how that Kauai fault zone was really moving open. We don't have the GPS data to show that movement like we have today, but just like we're showing all those pieces of ground moving, that was happening then as well here as well. So that's a similar view there. Another similar map. I won't go through the sequence again any further, but I will come down to the maps to show you guys, which I'm going to skip this other 74 stuff. So almost there. All right. So, okay, so here's all the different fissures, historic and prehistoric, in this Kauai area, showing where this can erupt. So there's a December 74. We just saw eruption in June of 2024 along this similar kind of pathway right through here. Right, we've kind of ruled out this upper southwest rift because of Mauna Loa, perhaps, but there have been historical eruptions there as well. In Halemaumau, we've seen plenty of those in the last 6 years. What we haven't seen as many of is this population right through here, and that's the one we're examining today, of July 74, of August 71, and other historic times as well. There's a couple in the middle part of this upper east rift connector, but really not many. It's really back to the southern part where you're starting to picking up again as well. There's a little bit of a gap right through here. Right, so it's going to show the boundaries of what's in play today. Let's see, that's 20. Let's come down to over here. They also did a lot of surveys leveling the ground to figure out where the ground was inflating during 1974. And they've marked this here with stars. And so the point here basically being, for 3 different intervals of time, April to July, inflation was here. From July to October, it was here. From October to January, it was here. So they're not picking it up week to week as we might with our instruments today, but they're actually showing a very similar pattern of the inflation center moving around the South Caldera area, closer to the Kauai, closer to the South Caldera, closer to the main caldera, but ping-ponging similar to what we're seeing today in those same areas, which is why you can see this as relevant here. Looking at the earthquakes, here are the earthquakes that preceded that July 19th eruption. And you could see there a big cluster in that upper east rift connector area, not too far from where we're seeing earthquakes today on Kilauea as well. Right, there is on the 19th, and the periods prior to that, just above here. And then one last one to show you guys from this paper. Let's see here. It's maybe this one, the Geological survey. They've actually went around and measured self-potential electrical fields and drew contours. And the point of this just being that that's what these lines are here, kind of showing this pattern like that goes around, just showing that there exists a structure underground that actually connects the South Caldera all the way south to this Southwest Rift connector where this 74 and 2024 eruptions have occurred right through there. So when we're seeing the earthquakes happening, it makes sense that they're happening right through there. And in context, there's the July fissures, there's the northern ones, and there is the southern ones as well, both of those on that same day in July. So pretty similar to what we have going on now. That was 74. I think it's worth stepping back to 71 as well. This is an image from 14th of August, 1971. Very similar fissure across the caldera floor. It went further over, I believe. Fissure across that little wedge of land between Kanakakoi and the main caldera. But that was the extent of it in 71. It did not go quite as far as the 74 extent. Similar image there as well, a little grainier. Another grainy one too, viewed from above. Here is that main caldera floor fissure, and then up across the edge of the caldera right up through there, sending a big flow towards the cliff below Volcano House. That's to the east. North would be kind of that way. So that's 71. 71, there's only one paper for this one from Duffield, Christensen, Koyanagi, and Don Peterson once again here. And what's interesting here is that Mauna Loa was active from 69 through early 71. And it was only in June of 1971 that they saw the lava start to drop in Mauna Loa. And that was a blockage of the East Rift and a magma starting to back up. So our story as far as what happens to cause eruptions in this area in this chapter of 71 begins there in June, where this is actually dilatation. It's not exactly tilt, but you can think of it as a similar to our GPS or to our tilt here. Our inflation starts skying in June right here, actually right through there. We have an eruption, and then the rate keeps going as if nothing had happened. And that's very similar to what we have going on now, where we have our inflation rate still going up very quickly. Even though we had an eruption in June, it really didn't change a whole lot as far as the state of the volcano. So pretty interesting analogs there as far as how this came in. We can continue looking for parallels. They are measuring inflation centers, and this is hard to see here. There's a little bit of shading of the inflation center early in June 71, later in June, later in July to early August, altogether June and August right in there. So just once again showing the inflation center bouncing around in the southern area of the caldera when this kind of filling underground pattern is ongoing. So once again there, showing the directions of tilt and contours drawn, where is the highest amount of ground upwelling after the fact was right there as well. In fact, there's a trace of the fissure, and there's a shape of the flow that went down below Volcano House, which is more or less in there. So that's 71, and you can look in more detail at how far the ground actually was rising in contours. This is, I want to say, centimeters, or is it millimeters? Yeah, in centimeters. Right, so you're looking at 20 centimeters right there near the eruption site, but the area that's showing uplift is going all the way out to the edge of the Kauai as well, all the way down through here. That's pretty interesting to note that as well. A couple interesting things about the 71 eruption. It was really super gassy. I think the same thing was true in 74. They noted maybe 40% volume loss in 71. I want to say that in the 1974 one, a lot of lava was shele pahoehoe, and in some areas, 80% of it was gas. So that's where you don't want to be walking around. It's mostly void space to fall into, and very harsh landscape, these 74 flows. Okay, once again, there's the fissure line and where the inflation center was. So I'm just showing that same pattern as 74 and as we're seeing here today. So there's not too much more to show on 71, except that to say that following the 71, there was the, as I mentioned, the 71 Southwest Rift eruption. There was then in 74, following the 74 event, there was a 74 Southwest Rift eruption. And right now we're in this pattern where we've had our own Southwest Rift eruption, and we're seeing Southwest Rift activity. Here's the dike that came through in early June. The flows 3 or 4 miles from the summit, but the dike reaching much further down than that, big distances. So as magma fills this whole area, it's able to flush out and move the excess down in the Southwest Rift. That's been possible thus far and happening, but at some point when that stops happening, that's when we might see it pop out somewhere else, whether that be in that South Caldera area, an Upper East Rift connector at the northern end or the southern end, or somewhere in between all of that. So there's the May to June, but this goes back to January and even back to October before then of how much Southwest Rift adjustments we're having going on here. So to run off this talk of this era in time, I thought I would show you the earthquakes as well. So first, let's show you, this is 1974 right here, and I'm showing you from June 1st to August 1st, right through here. Some earthquakes underneath Halemaumau. There's actually quite a bit in Kīlauea. Mauna Loa is actually showing how active it is, maybe why we wouldn't have an eruption in this shallow Southwest Rift, but there is our earthquake swarm that corresponds to the eruption that occurred on July 19th, 1974. So let me zoom it in and let it play a little more zoomed in. Eruption site's going to happen right here, but the earthquakes actually occur offset to the south near Puhimau crater in the thermal area back in there. So it's pretty subtle, honestly, right? Pretty subtle. There wasn't any huge escalation. Certainly the earthquake pattern we're seeing nowadays would qualify as similar. And at any point, if there's enough weakness coming upwards, then it could do a similar thing, popping up to the surface to erupt in the South Caldera area. The difference being that in 71 and 74, the eruptions in a summit happened first, and then it went to the Southwest Rift, whereas now we have already got to the Southwest Rift, and the question is, can we back it up and go in reverse order? So we don't know. We'll have to see. Here's 71 as well. Let me zoom it. Let's get a little more zoomed in here as well. 71, I'm going from May to September. So some South Caldera earthquakes happening there. And then here comes the eruption. Just a little bit extra earthquakes in the Upper East Rift and South Caldera areas and the summit. Kind of right through there was where that was flaring up. So once again, pretty subtle. Certainly not as intense as anything we've seen in recent months here. Which really brings up the question, is it possible for the volcano actually to erupt from these areas now, or are the dynamics actually different where that would have happened already? And now there's pathways into the Southwest Rift and into the Southeast Rift connector to accommodate that excess. And so we're just painting the background of this, of what's happening now, and we'll have to wait to see what actually happens when Kilauea does herself. So the last point with these earthquakes to share is, now what I'm going to do is zoom way out. I'm going to put earthquakes here in between the two East Rift events of significance of the era. So in 1960, there was a Kapoho eruption way down in here. And so I'm going to start my period in 1961. And in 1983, we have a Pu'u eruption beginning in the Middle East Rift that lasts decades. So I'm going to stop my window at January 1st of 83. So we're looking at 61 to 83, this period in between these rift eruptions, with a caveat that it does also include Mauna Ulu's eruption that lasts 5 years in the middle of here as well. So I'm going to let this play and loop through, and it's going to be a lot of dots, and it comes kind of fast, but I'll highlight what I want to highlight as it animates through here. First of all, there's a lot of background activity kind of all across the board, right? Including quite a bit on Mauna Loa. Mauna Loa is actually building pressure against Kilauea for quite a while before this phase of 74, 75. But on Kilauea itself, the magma is, after Kapoho, is having to inject and refill this whole Kauai region through here. So you see earthquakes kind of in that whole triangle as well. You see the south flank south of there as well showing adjustments, right? The big pulse comes through in 1974. This whole pattern going down that way right there is that December 74 eruption, when the lava actually swept down into this seismic southwest rift, erupted. But then following that eruption, there were 2 more weeks of earthquakes that progressed southwest and essentially released the southwest flank of Kilauea. This whole part of the volcano right there had to move, right, in order to allow this other section to move as well. So I was trying to think of a good analogy for this. It's kind of tricky to have you understand what's really going on here, right? There's a big block of land that's shaped like this, and it's trying to wiggle its way out so that it won't end up in a position slightly offset towards the ocean like that, right? So it's got to change and go off. It's just going to move over. And I was imagining like a car trying to parallel park. You got a car parallel parked right there, and it's got a couple other cars really close to it. And it wants to move out, so it's got to do this little shimmy. It's got to wiggle back and forth and back and forth and back and forth and back and forth and back and forth to wiggle its way out of there to create a gap between where it is and where it was. So in that context, this whole piece of land of the south flank is doing that little shimmy. And if the southwest part moves, that seems to allow the central southern part to move as well. So let's play it through. Right when a spike comes is going to be the southwest rift push that happens. And shortly afterwards in 75 comes that 7.7 earthquake of the southeast flank. So it goes bam, bam, southwest and southeast. Right, let me play it one more time. Let me fast forward it here. There's our southwest coming in now and southeast right afterwards. Just going to show how it did that shimmy, wiggled off, and then continued pulling out this way. So all in all, very dynamic time in Kilauea. Not to say you can't have a long-lasting eruption like Mauna Loa in the middle of all this, but this is ultimately what all led to 35 years at Pu'u'o, was the fact that you were able to wiggle open this piece of land. And the only way you were able to do that was by wiggling open this piece of land first. And so how long that takes is years. And whether this pattern we see today will exactly mirror what we saw in the past is not likely, but we can't say exactly how long it will take and how it will progress. But we can see the same ingredients right now as magma is basically prevented from going into the Middle East rift, where it prefers to go almost all the time. That's where it likes to go whenever it possibly can, and it's not able to do that, and so it's having to make all these other adjustments to eventually open a pathway to get back in there in the months or years to come. So that's the full thing here on 7174. There is a caveat to Mauna Loa, so I think I will. Well, let's see here. That was all our volcano awareness presentation. But let's go to Mauna Loa here. And in our Mauna Loa monitoring, I will start off just by sharing this image, which is the distance change GPS north and south across the caldera back to 1965. So I'm curious about this period of time in the 60s and 70s, right through here. And here is what our GPS line would actually look like. It was rising slightly prior to 69. Then it's actually decreasing slightly, increasing slightly, decreasing slightly. This is the context in which the 71 eruption happened, when it was able to get into the shallow southwest rift. By 74, it starts really spreading much faster. And that's what forces, it's thought, the eruption site to go south to the seismic southwest rift, right? Let me make sure I'm being clear on this, right? It's the difference between erupting up here and over here. It's the shift, right? The shift over to the southeast that's occurring because Mauna Loa, if it's swelling, is holding closed the shallower structures, and it forces the deeper structures to become the pathways all through here. So all that said, where is Mauna Loa right now? Let me just jump to the bottom. Nope, not quite that bottom. Let's go to our 5-year horizontal component right here. This is our closest analog to that other plot. And we are still rising, in fact. And it's not that fast, but we have not yet come to a point where we've dipped down following the eruption and recovery. We still haven't come down yet. That has not happened, right? So in contrast to what you see here, like there's some previous eruption in 1950 had spiked us, and then now we're in this regular wiggle back and forth. So different situation. So Mauna Loa is still swelling. That's the 5-year GPS. If you zoom it into the 1 year, it looks more like this, steady upwards. Here's earthquakes for the last year, month, and week. You see more dots in the last year, but there's really not much compared to when it's really active, like we saw prior to 2022. Here's 2022, and here is our earthquake levels today, which are quite low. So we'll scroll it all the way up just to share once again the tilt stabilized for the last month. And looking in at Mauna Loa at the summit earlier today, all is quiet and calm and clear up there. And that's it for Mauna Loa as well. So we'll wrap it up here with our community corner this week. We're going to do this in 2 parts. There's actually a couple events that occurred over the past week that we were a part of, and a couple coming up as well. So to start off, we'll look backwards to last weekend. Last Saturday was Revitalized Puna at Bilikinoe Park Gym in Pahoa.
Yeah.
Dane, you and Ann Lou were there. What's your takeaway?
Yeah, so this was the, I think, 11th total reactivation Puna since the 2008 eruption. It was also the final revitalized Puna, at least with the funding that was provided by the federal government that helped make these possible. So there is still hope that these types of events will continue. Maybe not every quarter, but there is a plan to try and keep it going. So if, in case you missed it, Revitalized Puna is a community gathering where a ton of different information and nonprofit and government officials make themselves available and to give their updates on their own projects that they're working on. So, for instance, we had an update about the dredge of Po'iki, as well as some other things that were a bunch of other stuff that was covered in the recovery process. And I believe those are available on the Kilauea Recovery YouTube page. You'd be able to find a video there, the recap of the updates. But yeah, we had a table there. We got to unveil all of our new table materials and looked all fancy now. We got a bunch of comments about how good it all looks now. And we've come a long way from a blank table with a few pieces of paper on it to what we're able to do now. So yeah, it was a good event.
Yeah,
200
sure,
people
yeah.
there, maybe a little more, 500, I think, registered.
Yeah, that was great. Yeah, great show of community. Yeah, great to have everyone getting together as usual. And whether it happens in that venue under that name or not, I'm pretty sure we'll be gathering again in some way, shape, or form.
Right.
You mentioned Pohuiki. There was actually a meeting yesterday by the Limtiako Consulting Group at Pahoa Community Center, which you also attended. Do you want to give us a summary of that?
Yeah, so we've been working on this project for a while, with invited by the Kīlauea Ohana to help consult and help plan a little bit of the park that is going in down at Isaac Hale Beach Park. This is taking advantage of the land that was left to the 2018 eruption. About half of the park got taken. So now rebuilding the park and actually not just rebuilding, but adding a whole bunch of new things like a giant pavilion, security stations, storage for the lifeguards, haliva, which is a kind of a canoe shed, canoe hut that everybody can store all the canoe clubs can store their rigs down there. And we're really trying to make Po'iki, return it to a community fishing village where everybody went to gather, to share, to fish. And that'll coincide with the dredge, even though they are two different projects entirely. So yesterday was the first day that this plan that has been worked on with all of these different ohanas, the lineal descendants of the area, the old families. This is the first time the plan got put out to the public. So it's kind of exciting to see it shared out there and, hear the questions and concerns everybody had. There's a few good ones out there that, it's not everything that you would ever want in a park, but it's what we think we can do with the money that has been allocated, $4.9 million for this project. So yeah, it's a good meeting.
Yeah.
But I believe that this was also recorded, so Kilauea Recovery should be posting a video on this in the coming days.
Yeah, so we'll revisit those when we have videos to share with you guys. We'll come back to this and maybe highlight a couple other things as well. But thanks for that update, Dane.
Yeah.
And let me just roll you into the next one here, which is looking forward. This Saturday at Pohuiki, there is a festival, La Ohana o Pohuiki Festival.
Yeah,
what's going on
this
there?
one's a little bit broader than Revitalized Puna because we're going to have food vendors, crafters, and it's much more. If you've ever been to Pohuiki, it's all the families and people with ties to the area. It's going to be I'm literally looking forward to this one. Hoping the weather cooperates with us because it is an outdoor event. And it's going to be taking place between 10 a.m. and 4 p.m. So come bring the family, go swim, go check the beach. Plenty of things to do, plenty of people to talk to, and going to be a bunch of information available as well. So yeah, looking forward to this one.
Yeah, that should be good. Yeah, the vibe of having everyone back down there. I don't know when was the last time we had so many people down there.
And every time, every time that we've done it, it's with the state or with the county, and we have a bunch of representatives down there, and everybody's together to share, mana'o or like the stories or the specifics of what is Po'iki. So this is kind of everybody doing it for themselves, and that's awesome to see. Like Po'iki pick back up like that.
Yeah, this is more of the party, yeah, and less of the trying to convince people that our piece of land is worth something,
Right. It's a celebration almost.
Yeah.
It's going to be great.
Yeah, awesome. That should be awesome. Yeah, so we'll be down there as well. That'll be 10 to 4 p.m. at Pohuiki. Yeah. And that's the Pohuiki segment of our update here. And then one final slide to show on community events. This Saturday as well, the same day as the Pohuiki Festival, is the National Park 40th Cultural Festival being held at the Kahuku Unit. 10 to 3 p.m. Also with food and exhibits and interactions and cultural events and all of that, music. And then next week, prior to our next update, will be Tuesday, July 23rd. Kenichi Maehara, Pele's photographer, After Dark in the Park, will be one of the final ones here as they migrate their programs to close the visitor center sometime by the end of this year, you'd think. So we'll try to see what we can do at this one as well on the 23rd next week, Tuesday. So that's what's happening in the park, and that's a community corner. And I think that's all I have to share today, Dane. Unless you have more discussion you'd like to lead. I can't hear you, man.
I don't have anything more. I see Dano up there. Awesome. So yeah, I don't have anything more. We're at that time, and yeah, if you're down Poiki or down Lower Puna, come out, check us out this weekend.
Right on. Yeah, thanks for that, Dane. Yeah, appreciate everybody who's joined us this week. We'll be back at our regular time next week, unless something happens that causes us to come on sooner, right? I mean, the volcano is pressurized, and we're talking about how the levels are such that in the past this has caused eruptions. We know recently it has not so much, but it still could. And that's why the USGS still says that any significant increase in seismicity or deformation could lead to another eruption. So it could happen, but if not, we'll be back next week on Thursday at our regular time, 5 p.m. So until then, from HVERI, we have our ASL interpreters, Dano and Carrie Kaufman. Mahalo, you guys. Appreciate you as always. Mr. Dane DuPont, and I'm Philip Ong. Aloha, everybody. Appreciate you guys.